Hello everyone, welcome to our iOS programming course. Now, the first question is, what are you gain out of this course? You're going to spend a lot of hours and you definitely want to learn something useful. So let's go over the structure of this course. Now, iOS programming gives you a choice of languages. You can either program in Swift or you can program using Objective-C. Objective-C being the parent, the legacy language in which most of the iOS programming used to be done. Of late, in the last 5 odd years, most of the development has shifted onto Swift. Swift being the newer, cooler, and more modern programming language which is out there. It doesn't mean that you will not get to see Objective-C anywhere in the market. A lot of big enterprises actually have their legacy code already written in Objective-C, and there's hundreds of thousands of lines. And of course, without new investment, they're not willing to just go back and rewrite everything in Swift. And unlike some other programming languages where Android has given a path forward for Kotlin by providing a Java to Kotlin converter, though you have to take care of a bunch of items when you do those conversions, there is no such path available for Swift, which is you have to write Swift from background up yourselves. With that being said, even Apple has a lot of existing frameworks which are still in Objective-C, so no harm with Objective-C. But if you are starting to learn iOS programming now, the only programming language you need to be familiar with for writing new apps is going to be Swift. That is the path forward. Um, the reason I am dwelling over this a lot in an iOS programming course is because I'm going to dedicate a lot of my lectures on just Swift programming and how it actually happens. And the reason this is very important is because unlike some other platforms where if you're doing web development, you probably have done JavaScript somewhere and you come into programming as a full stack developer, and you can carry forward from there. Or even in the old times when you used to do Android development, you probably already knew Java and you used to then get yourself familiar with some of the intricacies of Android development, and you used to be on your way. Swift is used on some other platforms like some server-side development, but the only real adoption of Swift is in the marketplace on bulk scale is iOS programming. So if you are coming to iOS programming and you are doing a course of iOS programming, the chances are that you are not a master developer for Swift, or you want to hone your skills. If you are a master developer for Swift already and you just want to focus on iOS development, you can probably skip through half of this course and just jump towards the later half where I talk about iOS development. The first 50% of this course will primarily focus on Swift as a programming language, the fundamentals, and how you can actually leverage the strength of the language to get most of the job done. Now, what this course is not about, I have covered what this course is, and of course I'm not outlining all the nitty-gritty intricate details about well, I'm going to cover this in lecture 1, lecture 2, lecture 3, and lecture 4, but at a high level you will have half of your time dedicated to Swift and rest of the half for iOS development. What this course is not going to be about is object-oriented programming. There's kinda implicit that you understand and have a basic idea about the concepts of object-oriented programming, that you're familiar with what are classes, what are objects, well, instances, what is encapsulation, what is inheritance, what is polymorphism, and you can apply those. What we will do in this course is that we'll take those concepts, do a quick revision of those concepts, and then see how they carry forward and apply to the iOS platform. And some of the things are generally very surprising to developers who are moving from some OOP languages like Java, because they're very used to the concepts of objects and classes and inheritance, and they come into this world and say, people just don't always inherit other classes and just use extensions to extend the existing behavior of the class. And we will be covering those concepts in detail as part of this particular course. Moving on, this slide seems like a cliche, but what is programming? And at this point in time, you probably are thinking that, okay, what is this guy talking about, right? Because everyone knows what is programming and why is this particularly important. um, the reason I wanted to cover or spend a couple of minutes on this concept is that I wanted to outline why is the mobile programming so special, and I think that gets missed a lot. Now, some of this could be opinions which I have based on my experience in the industry, and others are free to have their own opinions. But let's go with this topic. So, in general, programming is nothing but a set of instructions that you actually provide to a computer to carry certain tasks. All good and dandy. Now, as programming evolved, um, you definitely didn't want to keep spending the time to actually tell the computer to how to do those instructions over and over and over again, which means that if I want to adapt to a print functionality, I definitely do not want to write the machine instructions every time I have to print something. So we started shaping our programs as reusable components, and those reusable components we would go forward and then package up as distributable binaries. You as a developer would take those distributed binaries and then you will invoke something like a print manager or a device manager, and then you say device manager, give me an instance of the printers, and then I'm just gonna pass you a byte stream and say print, and it's done. Now, the same is true for our mobile programming as well, which means is that there are a bunch of libraries which are going to be provided by Apple out of the box for you, and you will not have to worry about ton of stuff. Yeah, you will not have to worry about, well, how does I get the GPS signals, how I'm getting the coordinates. You're just going to call an API, check a bunch of permissions, which is very important because Apple is all about privacy and security. And as long as you have that data, you will be able to get most of the tasks done out of the box using the functionalities that have been provided to you by Apple. Now, one thing which conceptually I want you to think of when you think about mobile programming is the fact that mobile programming is a bunch of software which is running on the client machine, and that's a big difference, which is this is a bunch of software which is running on users phone. And I was very slow and careful about it because most of the time when we start thinking about programming, we're talking about is that some server or a desktop or a mainframe on which the software is running. But in here, the piece of code that you are writing as part of the Swift development, iOS programming, your entire app is actually executing on the user's phone, and that kind of makes it a thick client. Now, a lot of people will argue that, okay, well, no, Google and iOS both have introduced what they call as instant apps, and all good. I'm not arguing that there are instant apps available, but that also means is that just a lighter version of the library that's just downloaded onto your phone and then gets executed. The actual execution of code happens on your phone, which is very powerful because that's the true concept of distributed computing. You're distributing the load across to a bunch of machines, and for example, if I got millions and millions of customers, and I'm going to take the example of Facebook, which probably has a couple billion customers out there, they, for them it's very nice because suddenly they have distributed all this load and processing power to the processors which are present on the phones on all these machines, and now they're definitely talking to some services which is present in the back end, but at the same point in time the front end logic is all encapsulated and is being executed on the devices itself, which is all good and great because it means the performance is just going to be swell, and that is a big criteria. Now, there are some lines of thought about having all the development done on the web, and I think that's where a lot of people who are just new to mobile programming, when they come in, they think that, hey, we want to code once, write anywhere, so let's go with web. And that's where they primarily go wrong, because if you care about customer experience, then native apps is the way to go. And again, there is a lot of discussion arguments about this topic. A lot of forms have been written. I'm going to provide some references in the notes as well for you to refer to those discussions. But my personal take, if you are actually interested in user experience, you have to go native. And that exposes, or that provides you with a lot of capabilities, because now you suddenly have capabilities like camera captures, co-locations, low energy Bluetooth, a bunch which are available on the web also nowadays, and more enhancements are being done. But a lot are going to be restricted on being be able to be accessed on mobile web, even down the line, and of course the experience will actually suffer. With this, enough on this topic. As I said, I will provide a link at the bottom on where you can actually go forward, navigate, and read more details about native versus hybrid options. Let's move on to languages of choice. Now, we talked about mobile programming. We talked about the fact that it's a thick client. What we have not talked about is, can I use Swift to write code and apps which will run across all apps? Again, the notion keeps falling back to write once, run anywhere. And there are a bunch of platforms, languages which are out there that support that, but you probably have got a feeling so far I'm not very supportive of them, and we cover the details on those. Let's say you're doing iOS programming, then you have actually got just two languages of choice. You have Swift and Objective-C. Objective-C being the legacy parent language, and Swift being the newer modern language. Now, this course is going to teach iOS programming using Swift, not using Objective-C. Like I said, Objective-C has been a wonderful language, has existed for more than 20 odd years, but it's a legacy language. So improvements have been done over the years. Even when ARC was introduced into Objective-C, there was a big step forward, but down the line, most improvements you will start seeing only in Swift. The other big thing is that Apple actually has started providing all its documentation of their newer APIs only in Swift and not in Objective-C, which means is that if you really want to use Objective-C, and you can, there are Objective-C bridges, and Swift to Objective-C, Objective-C to Swift, both bridges are actually available. Using those bridges, you can actually invoke one language from the other language. It's totally doable. Uh, but you might not get most documentation handy. Now, a lot is auto understood thanks to the syntax which is used, but still you might have to do some digging and then figure out why the app behaves in a particular way, and may not always be very explicit. So my recommendation is, if you're doing newer iOS programming, stick to Swift. Then the second question which comes in, then okay, fine, I'm covered for iOS. What about Android? Android seems like a big enough customer base, and especially in emerging markets, the Android footprint is just massive. And you're right. And on Android, if you want to create a native app, you have two languages of choice again. And um, there are more, but I'm going to talk about the major adopted languages, and that's Java and Kotlin. Java being the legacy now, and Kotlin being the modern programming language that's going to be supported in the future. The advantage between Java and Kotlin, moving from Java to Kotlin, is first you get the modern programming language format, plus you really don't have to um, worry about manually going in and writing all the code up from bottom. Uh, just like Swift and Objective-C, Java and Kotlin are fully compatible. That's good. But at the same point in time, the Android Studio IDE also provides an option to convert the existing Java code into Kotlin. And granted, that means that not all conversions will go very smooth, or you will require manual implementation, and you will require code reviews to actually see what's off. But at the same point in time, you at least have a tool as a starting point to get familiar. And get the bulk of the piece done. And hopefully you're doing test-driven development, and if you're doing test-driven development and you do this auto conversion, then execute your tests and make sure that everything is cool and dandy. And if you are not, um, hold on, we will be covering a pieces on how to do test automation in mobile world as well. That being said, there's another side note which I want to do. One of the biggest questions which I kept getting asked was, why didn't Apple and Google basically decided to come up with a common open source programming language that can help the developers create apps in a single programming language? Granted, just like form factors and device types, certain capabilities will be available on certain devices and certain capabilities will not be available on the devices. um, I personally think that it was totally doable. I think when Apple open sourced Swift, that was a big signal for Google to come in and get on the Swift bus. But then I also believe that from strategic perspective, um, tech strategy to be precise, it makes sense to maintain some differentiation. I think that's what Google went for. I'm pretty sure Google would have looked at, though I have no internal information, so I will not claim that I have any internal information. My hunch would be that Google would have looked at Swift at some point in time, but decided to go with Kotlin just to maintain that level of differentiation in itself. Now, Kotlin is more like an outside wrapper. So internally, you can have Kotlin compile the code into bytecode, which is Java, so that can run fully compatible with the existing Android platforms. You can also use Kotlin to convert to JavaScript for that matter. I'm pretty sure it's not that far away when Kotlin to Swift converters will come into picture, and which are more powerful, and they exist today, and that's why I'm just taking a step back when I say that. It's called Kotlin native, and not a huge fan again. And my reasoning, again, open for argument, and a lot of people have different opinions, but my reasoning around not being a huge fan for Kotlin native is because it's like a catch-up work, which means is that instead of you doing the work, you said that there's a group out there who is always going to be responsible, saying that whenever Apple introduces new APIs, they're going to work about incorporating all those changes into Kotlin native so that you can keep happily using the existing APIs or the APIs which are provided by Kotlin native, and then actually invoke functions which are present in Swift for iOS world. Now that catch up can take a few days to few months depending upon the complexity of change and the advanced notice which Apple might have provided, which Apple is not known for providing advanced notices. They are known for surprises. So not a big fan of going that path. Now it also depends upon what your purpose of your app is. Now if you're a big corporation who's very customer driven, and a lot of business comes from providing these cool features to the customers, then you want to stick to native. But if you are an app which is laid back, you want to just test the waters, maybe, right? But one point about Kotlin native would be that if you really want to try it for non-UI pieces. Do not really try it for UI pieces. Now moving outside of this domain and talking a bit on React Native and other platforms which are more focused on write once run anywhere, really have not seen anything which is really robust and durable. Now, the bunch of options, some are like hybrid options, and you can start thinking from a pure hybrid option where it's running on mobile web, which is run on all platforms. So you will basically go in and actually host the UI on a website, and then inside your native app you will have a wget web view or a custom tab, and you will open up that content. Yes, you compromise on customer experience and get that done, doable. Then they're going to some extreme pieces, which is, well, I can actually go forward and package all this JavaScript and HTML as part of the app and ship it out. Yes, again, doable, but then now you are making more design trade-offs. What you're doing is that I'm trying to improve the performance up a bit. Again, I said up a bit. It's never going to be compatible to native. um, I've tried that, and I have seen that you will still see a significant amount of lag, though the performance does improve, of course, as compared to downloading every content from a server. But you will still see a performance lag as compared to the native experience. The performance will improve though. At the same point in time, the drawback that you would suffer is that you lose your capability of doing remote updates, which means is that, well, earlier you could have just deployed changes happily on the server. Now the JavaScript is locally on the device, so you will have to build something which is something which does a checksum or freshness check and says that, okay, this content on the device is not fresh, let me pull up new JavaScript and HTML from the server and then maintain that. So that has to be done, so you make the design trade-off. Other thing is, like I said, if you go start branching out into React Native and others, I have not seen any piece of code where you can really write once and have it run anywhere. Bunch of these civils frameworks that you talk about is that, well, you can, instead of spending 2x the time, spend 1.5 or 1.6x the time, so they're saving you like 40% on time, given you will have to compromise some bits on customer experience. And the biggest advantage it out is not that you are actually reducing the time significantly, but the fact that you have developers which are now trained only in React Native, or developers which are now trained only in newer language like Golang or something, and they can actually go out for both iOS and Android. Earlier you were creating these buckets, and one was set of iOS developers, one was set of Android developers, and they would do their merry things, which means that you can't have this flex staff. You had probably, let's say, two iOS developers and two Android developers, and one got sick. It doesn't mean that an Android developer can jump in and really fill in. Though, as you would see, there are a lot of folks like me who can actually program on both languages and doable, but then just means that that's a difficult skill to actually find. So that's primarily the selling point of these frameworks. But one thing which I will again fall back to, if you are a customer driven company who is very focused on the customer experience, not the option for you. And one thing which you should do is look at the parent companies who introduce some of these frameworks, not targeting any particular framework in general. In future as well, if a new framework comes in, bunch will be open source, but there will be one main contributing partner. Look at the main contributing partner, and then look at the app provided by the main contributing partner. If the app provided by the main contributing partner is really using the same framework for the high traffic areas, then that may be the framework for you. But if they themselves are not using the framework for the high traffic areas, then they themselves saying that it's not up to the mark if you are customer driven company. And yes, for the low traffic areas, you can start using these particular frameworks. Enough talk on different languages which are out there. I hope you have a brief idea about what are the differences between the different languages. And now we are going to move forward to our focus area, which is going to be Swift in the first half of this particular course and Objective-C in the later half of the and iOS development in the later half of the course. Now, I I think I have repeated this like n number of times so far. I have said is that, okay, the first half of the course is going to focus on Swift as a programming language, and then later half is going to talk about iOS development. The question is, what is different, right? What are two pieces, right? I'm programming and I'm writing in some language, and you are saying that yes, Swift is the programming language that we're going to use. So all good and dandy. But what's the iOS framework bit, right? And would I have to learn something totally new for that? Not really. A programming language, and then this goes back to a couple of slides back why I introduced the concept of what is a programming language. A programming language is just a mechanism to provide instructions to the computer on what gets done. So you will, as part of the syntax of the programming language, you will learn is, well, how do I first start on a programming language, what operators are available in the programming language, what data types are available, what collections are available, what kind of iterative functions which I can execute, how do I write these common reusable functions, how can I segregate my code into classes. But then just because you know the programming language does not mean that you can issue a device specific instruction to go and fetch you the code location from the device. You need to know what APIs are available, and that's where the concept of a container comes into picture. The way you can actually start conceptualizing is that your code or your app is not running in a world where you are just giving instructions directly to a Swift executor, or because you already have the compiled code, so you are not giving out machine instructions directly out and saying, okay, do XYZ. You're actually running in a container. The container is providing you a bunch of functions and also defining the boundaries of what you can do or you can't do. For example, using Swift you can read files, all good and dandy. Does that mean that I can go and write code on iOS and go and read the content of the entire file system? If I was able to do that, then from competitive edge perspective, this is very awesome, because now suddenly I'm thinking about, well, I'm gonna go forward and read all the information out and quickly go forward and find out whether my user has my competitors apps installed on the device or not. What kind I can device fingerprint, and again there are means of device fingerprinting, but I can now really pinpoint because I have full access to the system, and I'm a malicious actor. Then it's even sweeter for me because I can be putting bits of information here and there, leaving those bits of information to come back and exploit that later. That's not going to be true. And again, like I said again and again, iOS is all about security and privacy. So the bounds of what you can do or you cannot do will be defined by the operating system. You will run inside a container which is called a sandbox. That sandbox will provide you a bunch of functions, and those functions can what we consider life cycle functions as well, will give you notifications, callbacks, actions on when certain events actually occur, plus provide you a lot of utility functions, procedures, using which you will not have to worry about a lot of things that you really need to provide a rich user experience. You may want to show a user the nearest coffee shops to their current location, and you will not have to worry about understanding the GPS coordinates and then converting a bunch of those into lat and longs. But yeah, that functionality will be provided out of the box by iOS itself. You would just call an API. As long as you have the right permissions, you will be able to get the lat and long, and then using the lat and long you will use the service to actually find the nearest coffee place available to you. You will be able to use the camera APIs. You will not have to worry about coding and thinking about is that, well, if my device is running on iPhone 6, 6s, 7, 7s, then I'm gonna use this interface to open up the camera for X number of milliseconds and capture the data. You will just call capture functionality, which is provided by the camera libraries, and then you will be on the merry way to capture the byte stream of the picture, and you can use it for uploading, you can use it for performing functions like mobile check deposits or sending your assignments back to your professor. So the biggest difference here is that Swift is a programming language. Cocoa Touch is a framework which provides you lots and lots of frameworks. Like there are hundreds of frameworks which are out there, and those frameworks each provides a unique set of functionality. Now you will not jump into all those frameworks immediately. You will not need to know all about them. You will use them on a need basis, and very awesome documentation has been provided by Apple on all those frameworks. Apart from that, you will also keep hearing about the words like UI presentation frameworks, MVC, MVP, MVVM. We'll covering a bunch about them in the future classes. At a high level, we'll also covering a bit more details about them in the future slides. But you can start thinking about them as they are just frameworks for containing some presentation logic. A bit more about frameworks which we're talking about. Like I said earlier, Apple provides tons and tons of frameworks to do almost all the tasks for you, and this is not a comprehensive list, just like just a snapshot to show that all these frameworks are actually available to you out of the box, and you will not have to worry about them, and you can just start using them. If you are a game developer, you are a 3D AR developer, then you can use those frameworks to provide you all the set of functions to create a meaningful experience for your customers. You will not have to worry about intricate details. You can actually use the frameworks to go forward, capture videos. You can co-location, Bluetooth low energy. So all their functions will be provided by the respective frameworks. We'll be covering a few. Rest, of course, I provided you a link, and if you click on the link, it opens up the Apple developer website, and this is one place you would want to become very, very familiar with. There's documentation available for almost everything. If you're designing your UI, how do you define your UI to meet the human interface guidelines? How to use the new features and that have been provided by Apple. You will have documentations available for all those. There is documentation available even for the Swift development, and in fact, the Swift development cookbook whose reference has been provided in this presentation is a very important guide that you should read through, and you will get more and more details about how to do Swift. And Swift, again, a new version of Swift is released every year. It's stable now. What I mean is, up till last year, whenever Swift will release a new version, you will have to go forward and recompile your code because syntax of Swift will actually go and change. Though I think after a couple of versions of Swift, Apple provided a good enough option for you to go in and just decide to convert your legacy Swift code into the more modern code with suggestions. So those functions were made available, but at least you still had to go forward and do those tasks, and it was cumbersome and painful because when you start thinking about big enterprises, you are again thinking about these big corporations having their own custom dynamic frameworks, and don't sweat over it. What is the dynamic framework and what is this new topic that has been brought now? We'll cover all that later down the line, but you can think that again within your own corporation you might be interested in providing these reusable set of libraries. And if you do, and let us say I have this wrapper app which uses like 10 dynamic frameworks that I have shipped out. Now, yes, I'm gonna take my app and convert the code, but now my app is depending upon these 10 dynamic frameworks, and some may be coming from a vendor, and they need to recompile the code and give me the new dynamic framework before I can start using it. So it used to be very painful, but now Swift is ABI stable. Again, it is ABI stable. The reason I'm highlighting this again is because most people misconstrue this to API, and I'm not talking about API stable. I'm talking about ABI stability, and I will not dig deep into that as part of this lecture, but the gist is, if you have written code yesterday for Swift and a new programming language came today for, let's say, next version of Swift is Swift 6, then it will be compatible. You will not have to worry about making code changes for having your code compiled, though certain will be encouraged because there will be older APIs which will be deprecated, but still your code can compile and then you will have time to actually make those changes. Now, jumping into the real crux, which is we want to go forward and do Swift development. How are we going to start about it? Now, here's where I talk about options. The best option which you have is always going to be Xcode. Xcode is the IDE which is provided by Apple for iOS development, and you can use it for doing your basic Swift development as well, which is non-iOS, just testing out the waters with Swift. You can use it, and that's just an awesome platform, awesome tool that has been provided by Apple. It's free, and I will cover through the steps on how you can go about procuring it in a bit. My recommendation: use Xcode. Now, one catch is that you can use Xcode if and only if you have MacBook, and it could be MacBook Air, MacBook Pro, Mac Mini, anything, iMac, but it has to be a Mac. You can't really run Xcode on Windows. There's no such version which is provided. And I think I'm on board with Apple here, because if you're a serious iOS developer who is planning to do iOS development, then you are going to be writing iOS apps, and to create those meaningful experiences, Apple needs you to be using a fully compatible version of IDE. And Apple can actually control the experience on MacBook Pros and not necessarily on all different platforms. Now here's where things get a bit different again from Android Studio. And again, I am an Android developer, as well as I would have disclosed earlier, but in the Android Studio piece, you get the ID, you get the language, but then you're dependent upon a bunch of other bits and pieces to join for you to get the full ID experience, or providing you the capability to actually go forward and generate the final app. You will be using the SDK manager to actually go out and download the SDKs. Your code inherently will be dependent upon ton of libraries which will not be included in your IDE, and you will be using the Gradle build system to go forward and download those binaries. And that's one way of doing that, and I understand and might have my own opinions on that particular way of development. But with Xcode, you get this Xcode and you get everything. You really don't dependent upon going out and getting, well, you got Xcode, but now let's go forward and grab Swift from there, or now let's grab the SDK for compilation for Swift 5 from here, or Swift 4 from here. You will not have to do all that. Everything is actually included as part of the Xcode package, and getting it is actually pretty easy. All you have to do to get the Xcode is, you have to go to your App Store on your Mac. You will go forward and search for Xcode, and you will go forward and hit the download button, and you have the Xcode. Now some of this I will actually cover in the later slides, so we'll come back to this topic in a bit, but we'll focus here more on the terminal and the online playground option. The second option which I'm going to talk about is the terminal option. The reason this option actually exists is that for Swift development, you really are just playing around with Swift, and you really don't need Xcode for it. You can actually do some of these actions from command line. But as you start building more and more complex programs where you want to organize the code nicely and then go forward with the execution, I don't think that you will be using terminal a lot. But just so that you are aware that the terminal option is available. It does supports the REPL structure: record, evaluate, play, and loop. So you can actually use it to execute your Swift programs. We are gonna do one quick demo here. So once you have Swift available, best way is actually to get the Xcode again. So assume I have Xcode, assume that you have Xcode. If you really want to explore the terminal option, all you do is that you type Swift. Now that opens up the new shell, and as you can see that, okay, I'm using Swift version 5.3 and some Clang versions here. I can always type help, and I can see now what are the different options which are available to me. And of course I have a lot of options available to step through different pieces of the code, to analyze memory, to see what are the different values of variables in the memory stack and all that. I will not be going through all that. What we will be using for this course will be Xcode for all iOS and Swift development. But this quick demo is just so that you become very familiar with the options which are available, and not all these options are new for you. Again, we'll coming back to this to show how hello world can be done in the terminal world, but I will going back to this in a bit. Now let's assume that you don't have a Mac handy and you want to know about Swift. If that's the case, that you just want to test some water, see if you really like the programming language or not, and you really don't want to buy a MacBook immediately, you have an option to actually use this free online site, which is online swiftplayground.run. Again, I am not affiliated with this website, and I cannot guarantee uptime, availability, future. This website being free, currently it is free and available. As soon as you open up the website, you see that you land up onto a screen where you can go forward and write bunch some pieces of code and then go forward and execute them, all good and dandy. I'm going to quickly show a demo where I was going to write the same thing like print hello world, and we are going to just go forward and run it, and hello world, nothing magical happens, but it's basic concept that, okay, if you really want to follow along this course and learn Swift programming language and see if you really like it, and if you really like it, then only you want to buy a MacBook, then that option is also available to you. You can use the online Swift playground to do the same for you. We can definitely make these programs interesting, and I'm doing that just to showcase the fact that it's not that you can just print hello world. Don't worry, you will not understand a lot of syntax right now, and that's okay. So I'm just gonna define an integer. No worries, we are going to cover what all this weird lines mean a bit later. I can decide to bump this counter by 1, making it 1, and I can say is, and my counter is. Please do not worry or sweat about the syntax at present. Voila. And what I'm trying to showcase is that you can do all the stuff which I'm going to talk about from the Swift playground itself as well, and follow along. You will start having some problems when you start organizing a bunch of files, and again, a lot of options are actually provided here for you to explore. But at the same point in time, if you have a MacBook, I would not recommend you to go forward and use the website. I would just say that use this website only if you are demoing something, playing around, and if you are interviewing someone, maybe a good place for them to write a bunch of Swift code and test it out. Moving back, let's cover up our Xcode instructions, and before I do, I promise that I will do the same exercise on terminal. So let's go forward and do it. We were terminal, we typed Swift, and let's do this step again. :quit is to get out of the shell, okay? And so I'm going to go back in the shell. I'm in there. I can now write Swift code and execute it. So I can just gonna go forward with print hello world. Voila. And now you say, well, it's a single line of code. Does it mean that I can only do single lines of code with this shell? No, that's not the case. You can go forward and follow along the same example which we did with that online version. Define a counter, and then you can decide to increment the counter, and then you can decide to say, okay, hello world, and the counter now is, again, please do not worry, we will be unraveling the syntax as we go ahead in this course, but the idea is that all the pieces of code that I was writing can also be done from the command line, and that's all I want you to take out of this discussion. Let's quit out of the shell. Moving on, I definitely want to show and go back where I was talking about the Xcode and how to go forward and download it. Now I'm not going to download it as part of this video, and I have already pre-downloaded the Xcode onto my machine, and the reasoning is, if you go in, again, like I said, it's free, so do download if you have a MacBook. It is free, like I said earlier, and if you go forward, you will notice the size is 11.2 gigabytes. So please download it or start the download overnight, and it will be done by in a few hours, so you will be all set. But yes, it is a bit bulky, and the reasoning is again going back. Apple didn't want to worry about developers going out and grabbing each bits of information. Like, okay, I need one simulator to actually go forward and test my piece of code, and I've got none. And I'm going to emphasize on this again. I've got none, which would probably be the case when you start with other competitor platforms. But in here, you will be packaged with some latest simulators out of the box. And again, I'm saying some because again, all these simulators take size. So Apple didn't want to ship all the 100 possible simulators, because even if one simulator takes 1 GB, you're looking at 100 gigabytes in simulators only. So definitely Apple didn't want to do that. They wanted to start with the latest one for you out of the box, so you can go forward and test your pieces of code immediately. But if you really want a particular simulator to test something, then that option is available. In that scenario, you have to go forward and click a couple of buttons in Xcode, and you will get that particular simulator. It will take again some time because, like I mentioned earlier, these are bulky. With that said, other piece which I introduced was about frameworks, and I will be covering this in a lot of detail in the course. We primarily be focusing the differences between three different types of framework, which is MVC, MVP, and MVVM. For now, M always stands for model, and these are your data representation objects. For example, you are a shopping app, and in the shopping app, you definitely need to have something that represents the customer, something that represents the cart, something that represents items or products, something that represents ratings. All these are models that are present in your application. Then is the view component. The view component is a piece which is, I have got buttons on the screen, I've got certain labels. Someone is just saying hello Navdeep. Someone is telling me that based upon your interest, there are following other products that we would like to recommend. That's basically a label. There are going to be hyperlinks to other content inside the app. There will be other actionable items. There will be tables inside it, slider menus. All those are views. Now, one of the biggest questions which I keep getting asked over and over again is, are storyboards and layout files part of the view or part of the controller? Now, I will cover them later in the course, but not right now, primarily because I have not exposed you the concept of storyboard, nib files, and definitely don't want to overwhelm you. But for now, let's keep things simple. Let's stick to the basic widgets and say that those are views. Now C here stands for controller, and you would see that C is the thing which keeps changing in all these frameworks. It changes to P, which is presenter in MVP patterns, and it changes to VM, which is view model, in MVVM model. And the intricacies get complicated as we look into those details down the line. But for now, I'm gonna give you a brief about MVC, and with the promise that MVP and MVPM will come later. So the idea behind MVC is to actually have more maintainable and scalable piece of code. And to maintain this piece of code, what we ask developers to do is segregate the layers, which is, you have views that need to be rendered on the screen. You have models which needs to have the data representation of what needs to be displayed on the screen, and you have to connect these two dots together. But you really do not want to tie the view to the model directly, and the reasoning is that if you tie the view to the model directly, then changes in model directly impact the view. And if you have got hundreds and thousands of views in your application, then you can imagine the repercussions of code changes can be huge from maintainability perspective. That's where the controller comes into the picture. The controller sits in the middle, is aware of the models and can talk to the models to get the data. It's aware of the views and can talk bidirectionally to the views, which is that it can push the data onto the views. At the same point in time, it can receive callbacks when an action actually happens on the view, like customer goes forward and clicks the button. The controller is the component which comes to know that a button action has been performed and something needs to happen. And the simplest example I can think of is considered a login screen, and you have a username and password text fields, and you have a sign in button, and the customer fills in the information, clicks on the sign in button. This action that has happened on the view, for that action something needs to occur, and that callback goes back to the controller. The controller now starts executing bits and pieces of the code using the data that has been made available from the view. We are also going to talk about our journey to the App Store, which is we wrote all these pieces of the code. Now I'm actually deploying this piece of code on the App Store. I will have to package the app, and the way it gets packaged is finally it generates an IPA file, and eventually we need to submit this to Apple for review. And post review, once Apple approves, the app goes on to developer hold, and you have a choice to release the app from the developer hold, and we'll be covering those details a bit later in the course. Now let's jump in. That's where the fun coding piece actually start. So let's open up our Xcode. So let's jump in and create our Swift playground. Like I said, okay, let's open up the Xcode project. Now we will not have anything created so far, so we're going to start fresh. As you see, there are a bunch of options I can create in Xcode project. I can clone from existing project. I can open a project file, but really I will have to start creating a project. And as I see underneath the line for creating an Xcode project, I read that it's for creating an app for iPhone and iPad, Mac, Apple Watch, Apple TV. And I think I just said as well, those things will come later in the course, and we start with just Swift. Is there a way to just go forward and play with Swift without actually creating a whole Apple iOS project? Well, there is, and starting with Xcode 12, Apple removed it from the launch screen itself, but you can still click on the file on the top. Once you have your Xcode selected, click on new and just say that you want a playground to be created, and you have a choice. You want a blank playground, a game, map, single view. Let's start with a blank playground. It definitely wants to know where you are actually keeping the playground, and I have created an iOS programming folder already created. I'm just gonna say topic 1, and that is it. You go forward and create your playground. It's there. Yes, it may ask me for my permission. You need to have admin permission on the machine you are actually using Xcode. That's how you would have probably installed it, and it has gone forward and created a playground for me. Again, it's saying hello playground. I'm just gonna say hello world. Don't worry about any of these pieces of code, and in fact you don't even need to import UIKit line here. I will just start with print. Let's say hello world, and it's just customary. It's customary to actually start with hello world, and that's why I'm actually starting with most of us would have started a development with any programming language with the hello world message, and I'm just following those customs. Now you will notice that I written this piece of code. Now what's happening? Is it executing? Is it not executing? And that's where this portion of the window actually comes into picture. You can click on this icon to tab between on and off, and you have this play button. As you move your mouse over the play button, it has execute option, so I can execute it, but it has this arrow which is pointing down. You can click on this arrow and hold, and see it's configured to run manually right now. I can actually choose to configure it to run automatically, so that I don't have to keep hitting the play button all the time. Okay, so as you can see, as I didn't have to hit any play button or anything, and just showing me the text hello world. Let's test out a couple more things. I can actually write print second hello. As you see, as I'm typing, the content and the changes are being made available. Now going back to our original example of counters, let's go and say counter, and as you will see that okay, well, it actually shows me the value straight in front of this line, and it does not print it in the log messages which are present at the bottom of the screen, which I can toggle on and off. The reasoning is I'm not really printing. This is more like the inspection view where I can actually go forward and see what's happening. And you can see as I hover over, I can actually take a quick look as well to see the values. And this is useful when I come to collections, not right now. I can always choose to bump the value, and as you would have seen as I was typing, the autofill actually notified me that okay, this is a variable which I've defined, and that's the one I probably want to bump, which is very neat feature so that you don't have to type a lot. Now I can say counter is and you see the change getting reflected on both the places. So this is what we're going to use in the beginning half of the course to actually do most of our practice with the Swift programming language. And as we move towards the later half of this particular course, we're going to close the playgrounds and we're going to come back to Xcode. And now it shows me what I had created, and we're then really going to create new projects like fully blown apps. And we're going to choose app, set next. Let me say hello world for now, and just after putting the name of the product, you see the next button is not enabled. What's important is for Xcode to know a org bundle ID, which is a unique way of identifying your app, and that's how Apple keeps track of your sandbox versus a different sandbox. So each company must define their unique bundle ID, and generally it's the reverse domain name. So if you are coffee.com, you probably are going to say com.coffee. Something specific about this app. So it's the Hello World app, so I'm just going to say Hello World. And Apple is just going to define the bundle ID as com.apple.helloworld.helloworld. So this is redundant. We're just gonna take it down because Apple's gonna take that from the product name. We're gonna use storyboards or Swift UI. For this course we're gonna focus on storyboards. I'm gonna use storyboards. We can include test as well to actually go forward and run. We can skip that for now, and those will come later half of the course. Skip up, define something like a hello world project, and just say create. And Apple has now gone forward and created the entire project for you. It's prompting me that I have not got an author defined, and we'll come to that topic in a bit. We'll define our accounts and go forward and add our accounts here. Now what we want to do is we want to go forward and see what these files are done, but again this will come later half the course where I dig into what is an app delegate, what is scene delegate, what a view controller is. But for now I want to see is that can I run it. So the easiest thing is I can just hit the play button and see if the code actually executes, which is running in a simulator, all good and dandy, but doesn't say anything, doesn't do anything. Did something happen? So let's just go forward and make a quick change because we want to practice hello world. So should say hello world at least. So for now know that this main storyboard will come to it in a bit, but this is the main screen which is going to be rendered once the app has been launched. This is a launch screen as well. We'll cover those details later in the course. For now we're just going to click on this object explorer, and we're going to take a label and we're going to drop the label down. We're gonna go forward and say that instead of just saying it a label, we're going to call it a hello world. And of course I would want probably a bigger size for my hello world. Okay, let's just line it up. As you see, these lines should come up to make sure that I'm lining it correctly. And now let's hit the play button again. So it's building the application again for launching, and launched. It's saying hello world. As simple as this, you got your first app out of the box. Granted it doesn't do anything and probably not the kind of an app you'll be launching, but still it shows the power that how easy it is to get the base work done and actually go forward and add the label. We demoed it here but we'll come back to iOS development much later in the course once we are very clear about Swift fundamentals, so that when you look at pieces of the code that actually looks like this, you don't feel scared and it all actually makes sense. Debugging. Now this is a very important aspect for any programming. How you're going to debug your code, how you're going to figure out where the issue lies. Is the crash because you have a wrong action or outlier which is configured on the storyboard, or it's just incorrect logic, the counters are off, so it's looping through an extra turn while going over collections. It's very important, and the way we can debug is by putting in breakpoints, and we will be covering that. I would not start in the beginning of the course with how we'll go about debugging, but I will show you as we go across different lectures inside the course on what are the best possible strategies for debugging where the issues may lie. In this section we talk about a couple of topics. One is code commenting, how you would go about commenting the pieces of the code that you're going to write, and the second one will be around string interpolation and how or what is the right way of doing so in Swift. Again, one term which you'll keep hearing me say again and again will be whether it is Swifty enough. And what we mean by that is that, yes, if you're coming from a different programming language background like C, C++, Java, then there are operators available even in Swift for you to accomplish the task in a fashion similar to the one that you have been doing in those programming languages. But in Swift, that's not how we do things. And if you show the code to an experienced Swift developer, they will look at the code and they will be like, well, it's not Swifty enough. So let's look at first the code comments, and then we'll move on to string interpolation. In Swift, there is an option for a single line comments, so which is well, I just want to highlight what the portion of the code below this line does, and I can simply go forward and strip something like prints a greeting message. And this is single line comments, but what I mean is that if I try and continue the comment on the next line, well, that's an error. That's not something which Swift really understands. So we will remove that. Now, if there is actually a need for a multi-line message, then you can use the /** operator to accomplish the same. And the way you will do it is that between the two stars, you'll just go and type the message. This is an example of multi-line comment. And of course, you can continue as many lines as you want until it finds an ending symbol, and that's when it actually stops the comment. The third comment which I really like is basically something where Swift auto provides a mechanism for you to go forward and generate the comment with all the necessary parameters which Swift thinks that you should be documenting for. So the way it works is that, let's say I have a function hello greeting, and please don't worry about the syntax right now. I know that I have not gone over functions so far, we'll come to it, but just assume that there's a method or there's a mechanism for writing the functions in Swift. And I go forward and I simply write hello there, all good. This function is not being called right now, so that's why you're not seeing the print message being shown automatically. But I can go here and I say command option and plus, and it's going to actually go forward and generate a comment for the function. And for this particular function, what I'm going to do is that for this particular function, what I'm going to do is I'm going to select the function and press command option and the forward arrow / which basically is the comment symbol. If I press command / then I got a single line comment. If I press command option / after selecting the function, it basically giving me commenting capability on top of the existing function with all the necessary arguments that could be true. So this looks like a single line comment, and you may come back and ask, okay, well, I don't see any difference, so what are you trying to say? Let's look at a function which accepts an argument. So I say hello, greeting, true, and now basically I am accepting some sort of an input. Again, don't worry about syntax right now, that will come later, but I can go forward and now simply print a message saying hello there and true. Okay, so accepts the name probably and then goes forwards and prints the hello message. Now if I press command option /, you see the comment which is generated changes. It's no longer just a description, but it has description and parameter. So Swift automatically is generating a comment saying, okay, this is all that you must go forward and document. And this is all you need to know about comments. Now we will move on to talk about string interpolation. Now let's remove a bunch of code that we have just written, bring it down to a clean state where we originally were. So we had bunch of print statements, and I'm just going to stick to my simplest example. I have a counter, increment the counter, print the counter. As you're seeing, I'm using something unique here. I am going forward and putting a backward slash followed by a opening bracket and a closing bracket. And I'm writing the variable inside it, and Swift is automatically understanding that it is of type string, and it's actually going forward and printing the full message saying my counter is 1. Very convenient. But then if you're coming from a different programming language like C, C++, Java, you can say, well, this seems like something we can easily do in those languages as part of string concatenation. So what's the big deal? In those programming languages, probably you will do something like my counter is, and then you will go forward and do the concatenation with the plus symbol, and you will go forward and say counter, and it will go forward and print the same message, but not in Swift. As you can see, Swift showed you an error message. It's not because the concatenation operator is not available in Swift, it is, but what you're trying to do here is you're trying to add a string to a number, and in Swift it is a no. Swift is type safe, which means is it wants you to explicitly declare what you are trying to do. If you want to concatenate a string to a string representation of the number, you need to say so. It will not auto convert it into the string representation of the number for you. So what you will have to do is that you will have to take the string, and then you will have to go forward and convert it into the string representation, and all is good. You see both print the same text, so it exists. So now the question comes is, if string concatenation exists, then what's the big deal? What's the big deal with string interpolation? And let's see this with a different example. Here's an example of you trying to just print how long a given planet takes to rotate on its axis, how many hours it takes, and how many seconds are there in a given day. I have used string concatenation here simply because I have text like a day on planet X has X number of hours and computes to basically N number of minutes. All good. But again, I've done a lot of string concatenation, and if you guys are familiar, then strings basically in most programming languages result in new object references being created. So even in C++ or Java world, this is not something that will be recommended. You probably in Java world you will use string builder to do the same operation, but it's insanely easy to do the same task in Swift. In Swift, all you have to do is you say is a day on, let's say some planet, okay, has some number of hours, that is some seconds, and that is it. Now string, of course Swift is complaining because it's trying to compile and say, well, there's nothing inside, it is empty, and we are going to plug in. We're just going to take the planet name, which we already know. We're going to take hours in the day and we're going to plug it in, and as you will see here, the string interpolation is powerful. Inside the backward slash, starting bracket, and ending bracket, you can have expressions, which means that you can do arithmetic operations inside it, and that's what exactly I'm doing. And all this piece of code that we had written to formulate this string now can be boiled down into a single line of string that is shown here, and that's the power and magic of Swift. In Swift, you want to do the task in the shortest possible fashion and that is available, not necessarily the longest possible fashion, and like it was shown here. And that's the power of string interpolation as we have demonstrated here, and we'll continue using it as we try and go over different exercises in this course. Stay tuned. Next we talk about operators.